Good day, everyone. I am Joevylyn Doronila, and for today, I am your science teacher. I hope everyone is doing great today because we are going to learn something interesting and useful about electricity. But don't worry because I'll explain everything in a simple and easy way so that everyone can understand. And our topic for today is all about electricity, the relationship between the current, voltage, and resistance, or also known as Ohm's law. So sit back, listen carefully, and let's enjoy learning. But before we start, I want you all to think the things that we use every day, like cell phones, electric fans, television, lights, and chargers, and so on. So all of these devices need electricity in order to work. But have you ever wondered how electricity moves inside a circuit? Well, electricity does not just move. It follows the certain rules and relationship, and one of the most important rules in electronics is called Ohm's law. In this lesson, we will understand the meaning of voltage, current, resistance, and how they affect each other and how to solve simple problems step by step. But before we discuss the three important concepts, let us first talk the history of Ohm's law. So, the relationship between the voltage, current, and resistance was discovered by a German physicist named by George Simon Ohm in the year 1827.
Through many experiments using metal wires, he discovered that electricity follows a pattern. He proved that the flow of electricity can be measured and predicted mathematically. At first, many scientists did not believe his discovery, but later on, his work became one of the foundations of modern electronics and electrical engineering. Because of his contribution, the unit of resistance was made ohm in his honor. Now, let us move to the relationship between current, voltage, and resistance. These three are connected by Ohm's law. So, this formula means that the current flowing in the circuit depends on the voltage and resistance. Current is directly proportional to voltage, which means if voltage increases, current also increases. But current is inversely proportional to resistance, which means if resistance increases, current decreases. To make this easier to understand, let us imagine electricity like water flowing inside a pipe.
First is voltage. Voltage is the electrical pressure that pushes through a circuit.
You can think of voltage as the energy that starts the movement of electricity. So, in a simple words, voltage is the pushing force of electricity. The unit of voltage is called volts, and the symbol is letter V.
Next is current. Current is the flow of electric charges inside a circuit.
If voltage is the push, then current is the actual movement of electricity. The more electrons moving through the wire, the higher the current. The unit of current is amperes or amps, and the symbol is letter I.
And lastly is resistance. Resistance is the opposition to the flow of the electricity.
Is resistance, so it controls or limits how much current can pass through the circuit. So in simple words, resistance can make it harder for electricity to flow. The unit of resistance is called ohms and the symbol is letter R.
Now, let us connect the three concepts together. Voltage pushes the electrons, current is the flow of electrons, and slows down or limit flows. So if the voltage becomes higher, more current will flow. But if resistance becomes higher, less current will flow. That's why these three always affect each other inside a circuit. So I prepared three problem set. So first is a circuit has a voltage of 20 volts. and a resistance of 5 ohms. So we have to calculate the current flowing in the circuit. So these are the givens. Voltage is equals to 20 volts and a resistance of 5 ohms. So since we are looking for current, we will use the Ohm's law current formula.
Now, let us substitute the values. Current equals to 20 divided by 5. So, when we divide 20 by 5, the answer is 4. Therefore, the current flowing in the circuit is 4 amperes. Now, let us understand the meaning of the answer. The voltage is strong enough to push electricity through the circuit while the resistance slow it down a little. Because the resistance is only 5 ohms, the current can still flow easily, resulting in 4 amperes.
Now, let us proceed to our second problem set. And now we are looking for a voltage. And here is the question. If a circuit has a current of 6 amperes and a resistance of 3 ohms, what is the voltage? So first, let us identify the given values. And here is the given. Current is equals to 6 amperes and a resistance is equals to 3 ohms.
Since we are looking for voltage, we use this formula. Now, substitute the values. Voltage equals 6 times 3 and 6 multiplied by 3 is equals to 18. Therefore, the voltage is 18 volts. This means the circuit needs 18 volts of electrical pressure to push 6 amperes of current through a resistance of 3 ohms.
So here is the quick summary of the three important concepts. So first is voltage is the push or pressure that drives electricity. Current is the flow of electrical charges and resistance is the oppositions to the flow of electricity. So these three work together in every electrical circuits. And that's the end of my discussion about the relationship between the current, voltage, and resistance. And I hope you learned something and understood of how electricity works inside the circuit in an easy and simple way. And that's the end of the vlog. If you enjoyed this video, don't forget to like, share, subscribe, and hit the notification bell for more upcoming educational videos.